Okay, so here is Unit Exam 6, Step 1. And you don't have to take notes on a problem if you got it right and you completely understand how to do it. And if you fit the criteria above for a problem and you'd rather not take notes on it, just write something like got right, understand, in the space below the problem. So, okay, so these, I think I lost track of which of these were secure problems and which weren't. And I'm just like super nervous that I know one of these for sure is not a secure problem, so we're just going to do that problem together. But for those that are secure, so on my video I've covered up the problem. I'm going to do a similar example, so you do the similar example with me, and then you do work to correct the problem until you arrive at the right answer. So the answer for the first one is C, and here is the similar example. And go ahead of me at any point if you feel like you've got it. So, all right, so this is a function, and we're going to find dy dx. So I look at this, and okay, so first I ask, is this a limit derivative or an antiderivative? It's a derivative. And I look at this, and I ask, well, how do I find the derivative of something like this? I've got to use product rule. So y prime is equal to, so the derivative of this first part is 5x to the fourth, and then I just bring down the second function, and then plus I just bring down the first function, and the derivative of natural log of x is 1 over x. Okay, and then we'll simplify just a little bit because with multiple choice very often you have to simplify in order to see what the right answer is. Okay, and then this is just going to be x to the fourth. Okay, and then in this multiple choice problem in particular that you're about to do, they factored out the greatest common factor. So, so here we go. So x to the fourth, 5 natural log of x plus 1. Okay, so now move to the work section and you do work for the problem until you can justify picking that as an answer. And then I'm going to move on. So number 2, the answer is D to this one. We're going to do a similar example, and then you're going to do enough work to justify that answer. Okay, so I look at this, and first of all, this is actually the same. Since the dx is like up top like that, that's sort of like weird notation, but it's exactly the same as this. So let's first rewrite it like that. And then you ask yourself, limit derivative, antiderivative. This is an antiderivative. And you ask yourself, well, can I do, you go down the list of things that maybe you can do to take an antiderivative, and none of them will work, so you have to use U substitution. That is the last resort. And when you're looking for what the U should be, you should choose a function that is inside of another function. So I'm going to choose x to the third plus 2 because that is inside of the square root function. And then you go like this. You go du equals, take the derivative, 3x squared dx. Then solve for dx, so I'm going to divide both sides by that. So you get that dx is, it's 1 over 3x squared du. If you said du over that, it's the same thing. Okay, and then once you have all this, then you plug in to this. So integral, and now this is 3x squared over radical u, and then times 1 over 3x squared du. And you will know that you did it right if the x's cancel. If they don't, then you chose the wrong u. Okay, now I'm going to bring this down, as u to the -1/2. And if ever I do something that's not clear, like if you don't know how I got from here to here so fast, pause the video and think about it. The goal is for you to understand absolutely every step that I take. Okay, and now I can do the antiderivative. So I've got to add 1 to the exponent. So it is u to the 1/2. And then you have to divide by 1/2. So divide by 1/2 also. And then don't forget the plus c. And the very last step is I'm just going to plug the u back in. By the way, dividing by 1/2 is the same as multiplying by 2. So that would be 2u to the 1/2 plus c. And then x to the 3rd plus 2 would go back in. All right? And maybe, like if this was multiple choice, as an extra step, you'd need to recognize that the 1/2 power is the square root. Okay? And now you're going to do this work to up until a point where you can justify picking D. And number 3, the answer to this is C. And we're going to take some notes here together. This similar example, we're going to do the area enclosed by y equals 3x and y equals x squared. Now this is a calculator section. So let's start by graphing those. So 3x and x squared. Okay, so there's 3x. There's x squared. Okay, so, and you don't have to do this, but a lot of times if you go zoom box, you can get just a better, like a more tightly controlled picture of your region. Okay, so I go all the way up like to that corner there and I hit enter. And then you just like go like this. This is totally like an optional thing, but this is a good thing to practice because there may be moments on the AP exam where you really do want to zoom in on a specific region. Okay, so there's that. Now let's draw a picture of it. Okay, so let's draw a little picture. So I've got this, and then we've got that. All right, whoopsie, I don't go under the axis though. That's a mistake. Whoops. I don't know. I'm just messing everything up. Okay, so there it is. And then you have to know your formulas for area and volume. So this is going to be the integral from x equals a to b, top minus bottom, dx. All right, because it passes the vertical line test. So this is going to be the integral from x equals this value here, all right, which we can find. I'll just tell you what it is now, but it's 0. And then this one up here we need, and that's going to be, let's review how to find this using our calculator. So you go up to this calc thing. So you go second calc, and then you go down to intersect. And if you find that it's easier for you to use algebra, like for me, actually, it would be easier just to use algebra faster, then definitely do that. But this is good that we're reviewing this. So the intersection point is 3, 9, that point. So the x value that we want to use is 3. And then you do top minus bottom. So the top, okay, so like you go like this, top, bottom. So the top function is x minus the bottom function is x squared. Okay. And then you could use math 9. So now I go here and I just go math 9, 0 to 3. You really want to take as many shortcuts as you can. X minus x squared, because time is of the essence. So negative 4.5 would be, what? That doesn't make any sense. Oh, because it's 3x. Oh, sorry. 3x Whoopsie, whoops, whoops, whoops. 4.5. Huh. Okay, 4.5. 4.5. All right, guys, now you're going to do similar work to arrive at that answer. And I'm going to keep going. Okay, so this is an interesting one. I like it. So the answer is C. And here we want to solve for k if this. So this is the integral from 0 to k of this function with respect to x equals 8. Now here's a clue, guys. Like sometimes it's like, why do they do the dx? It actually tells you what the independent variable is. So the fact that there's a dx at the end means that k is some constant. It's not the independent variable. So I think that's helpful. All right, now you ask yourself, limit, derivative, or antiderivative? The answer is antiderivative. On the left side, guys, on the left-hand side for a problem like this, you want to use the fundamental theorem of calculus. And I'll just maintain the equation, so bring down equals 8. Now what goes inside the brackets is the antiderivative of this. So the antiderivative of this part, I use power rule. It's 1/4 x to the 4th plus, and then this is going to be k over 2x squared, is that part. Okay, and then I'm going to plug in k. So this is 1/4 k to the 4th. Uh-oh, this is harder than I thought. I haven't done the problem yet. So 1/4 k to the 4th. Oh, maybe not too bad. Ugh. Or maybe it is. Darn it. Plus, then I'm plugging k in there, so that's going to be k to the 3rd over 2. Oh, shoot. Why is this not working out nice? I really don't want to start over. If I change this to a 3, would it be different? Okay, let me change this. Let me change that to a 2. Okay, I made the problem up, so. All right, then that would be a 3, and that would be a 3. And that would be a 3. So, yeah, I made the problem up without thinking too hard. So k goes in there, so k times k times k times k, so that's also k to the 4th. And then it'd be just minus, and then you're plugging 0 in, so it'd be minus 0 equals 8. Okay? And then, so we get, so this is k to the 4th over 4. Plus k to the 4th over 3 equals 8. You're trying to solve for k. So I would get common denominators over here. So you can get a common denominator of 12 by multiplying this by 3 over 3. So that'd be 3k to the 4th plus, here 4 over 4, 4k to the 4th equals 8. And then we get 7k to the 4th over 12 equals 8. You could cross multiply if you want. Yeah. And then we get 7k to the 4th equals 8 times 12 equals 96. So k to the 4th equals 96 divided by 7. So k is equal to... k is equal to, it actually should be plus or minus because we're taking the 4th root. Okay, so let's just say the 4th root of 96 over 7. And at the beginning, let me change, solve for k if that, and let's say, and k is greater than 0. All right, so I had to do some improvising in order not to start the video all over. So let's suppose at the beginning it said this, and then let's suppose that it was that instead, and then all of this work is good. So when you're doing your work to correct the problem over here, it's really just important that you know you're doing the fundamental theorem of calculus, setting up the brackets, endpoints of the interval, antiderivative inside, subtracting what you get when you plug in the endpoints, keeping it the entire time equal to the right side until you can solve. Okay. So now I'm moving on. Guys, for this one, the answer is D, and you just need to know your formulas. You just need to know your formulas. And I think most of you got this, and if you didn't get it, it was just because you just made a little mistake. So here you just need to use, okay, so you need to do, okay, so let's just write this down. For area, you're going to do from x equals a to b, top minus bottom dx, or the integral from y equals a to b, right minus left dy. All right. Okay, so this one here, because the region passes the vertical line test. Okay, and then we will just move on to this one. All right, so this is number 6. The answer is A for the problem that you're going to do work for. And here's my similar example. So find the equation of the tangent line to this function at this point here. So you ask yourself always, limit, derivative, or antiderivative. Well, if you're going to write the equation of a tangent line, you will need the slope of the tangent line. So you're going to be going like this. You're going to go point of tangency, which is -1, 1. And then you're going to need the slope, which in this case is going to be f prime. All right. So the answer is derivative. Limit, derivative, or antiderivative, the answer is derivative. And you're going to need to use product rule and chain rule. So f prime of x. So I have to go, so I'm going to go, so the derivative of this one is 2x, and then I just bring down the second function. Plus, you just bring down the first function, and then you've got to do the derivative of this one. All right? So maybe, like down here, let's go aside. And then you'd have to do like an in and out deal. So 3x plus 4 blank to the second. So the derivative of this inside function is 3. And if you could do this in your head, excellent. That's like the goal. But we want to be super careful, so I'll do this. All right, the derivative of the outside is 2 times blank, and then the old inside goes back in. So it's 6, and then 3x plus 4. And I'm like running out of room. So 6, 3x plus 4. Okay, so yeah, so this is f prime basically, and so here, this function, this derivative will give us the slope of the tangent line at any point. We want the slope of the tangent line at this point, so we want f prime of -1. So you just, so f prime of -1, all right, this here will be -2, and then this is going to be just 1, and then that'll be just 1. Why am I going like that? Do I have enough room? 6, and then this will be 1, right? I think I'm right. Yep, so then this will be 4. Yeah. Okay, and then you've got to go, okay, and then you've got to do y minus y1 equals mx minus x1. This is called the point slope formula. So y minus 1 equals 4 x plus 1 because you're going to subtract a negative 1. And then in this example, they have it solved, they have y solved for, so we might as well. Now, when you go to do this work to correct the problem, once you get the slope, guys, you'll notice that there's only one choice with that slope. So you're actually done. Once you find the slope of your line, you can actually stop. Or not stop, but you can choose your answer. You'll be able to see part A just from that. And the goal is to save yourself time. So you don't have to follow through and find the equation if, you can eliminate all the other choices with the slope alone. Okay, now, I thought that all of these problems were secure, and then I went to go search an example for revolving an ellipse around the x-axis, and this came up. So I don't think it's secure if somebody else posted it on the internet, but if they did, then they were wrong to do that. And okay, whatever. But I don't think that it's secure. So we're just going to do the same problem. So they want you to take this ellipse and revolve it around the x-axis. Now the answer we're going to end up with is B. So if you want to get a sense of what this looks like, then you can solve for y. So we'll get that 9y squared equals, because I didn't do ellipses with you last year in pre-calc, and I don't think you ever did them before. So yeah, you would just use your calculator to see what it looks like. So y squared equals 9 minus x squared over 9. I'm so happy I had you for pre-calc, by the way. That was so much fun. And this year is as well. Okay, plus or minus. So then you go to y equals, and so I'm going to graph, okay, so I'm going to do that alpha y equals thing. So alpha y equals, so 9 minus x squared. This way you avoid having to use a lot of parentheses. Okay, and then the negative part, so negative square root y equals 9 minus x squared over 9. Uh-oh. I'll go to a standard window in a minute. Oopsie. So zoom, standard. Okay, so there it is. So that's what an ellipse looks like. So we've got this, okay? And if you play around with your table, you can even see like that this is -3 and that is +3. Okay, now we want to revolve around the x-axis, and we're going to get the volume of the solid. So you need to know, since we're revolving around the x-axis, we're going to use this volume formula. Okay, and I don't know if I used this with you before, but we're gonna be using this. So x equals a to b, and in here goes the area. Okay, so in there is going to go the area of a cross section, and whenever, okay, and then so let's be like where a of x equals. Now in this case, guys, so since I'm revolving around the x-axis, this shape, okay, so the x-axis is where the centers of the revolution are. So like here is a cross section from here all the way up and then like revolved around. from here all the way up revolved around. So whenever you're dealing with these revolution problems, either the cross sections are washers or discs. They are, and by the way, this I should have shaded in the area. This is the area that we were revolving, and there's no space between the center of the rotation and the region. So these are going to be discs. So the area is just going to be pi r squared. So we get a of x is equal to pi blank squared. Now in this blank needs to go the radius of this circle, of these circles, which are always changing depending on the point that we're at. And since the length goes from top to bottom, you're going to do top minus bottom. So top minus bottom would be the top half of this ellipse, which is the positive part, and then the bottom would be 0. So it's going to be, yeah, so this, but the positive one minus 0. So it's just this, 9 minus x squared over 9, just like that. So it's going to be the integral from x equals -3 to +3, from -3 to +3 for the x values. And then just this area function is going to go in here. And guys, if you look at the choices, all of the choices have pi's in them, which means that they pulled the pi out front. And by the way, since we're squaring a square root, you could just plug in this. Okay? So the pi can just come down, and then in your calculator you go math 9 for the rest of it. Okay, alpha y equals 9 minus x squared over 9. And you get 4. Okay, so which is 4 pi, which is choice B. Okay, now this one, number 8, the answer is B. And let's do this very similar example. So given f prime of x equals this, g prime of x equals that, f of 0 is 3, and g of 0 is 2, we're going to find this. So you ask yourself, limit, derivative, or antiderivative? This is a limit. And whenever you're computing a limit, the very first thing you do is direct substitute. So this is f of 0 minus 3 over g of 0 minus 2. Which ends up being, so f of 0 they told us is 3. So this is 3 minus 3, and g of 0 is 2. So that's 2 minus 2, that's 0 over 0. So if this is 0 over 0, then we can use L'Hopital's rule, which says that the original limit is the same as the limit as x approaches 0 of the derivative of the numerator over the derivative of the denominator. Now be very careful. You're not taking the derivative of this entire input. For that you would need the quotient rule. This is not, L'Hopital's rule doesn't mean you do the quotient rule. It means you take the derivative of the numerator separately from the derivative of the denominator. So this ends up being the limit as x approaches 0. The derivative of the numerator, the derivative of f is just f prime. The derivative of 3 is 0, so you just end up with f prime. So, and then down here, the derivative of g is g prime. The derivative of 2 is just 0. And then you direct substitute. So this would be f prime of 0 over g prime of 0 equals, so f prime of 0, here's f prime. F prime of 0 is the square root of 4. It's just 2. And then g prime of x is always 7 no matter what. So 2/7. Alrighty, so you're going to do some similar work to arrive at that answer. Okay, now down here, I'm not going to do like a similar problem. Instead, we're just going to talk about this. Okay, so let's say it like this. If the limit as x approaches positive or negative infinity of some function is equal to a number, let's call it b, okay, then y equals b is a horizontal asymptote. Okay, so I know you don't have room to write this. Okay, so, but here's a picture. So like, let's say that this is B. Okay, and like this would be an example. Like say that that was F. All right, so like as we're approaching, this would be as we're approaching positive infinity. Okay, so now, I just took some of the inputs. I'm doing a bunch of limits. All x approaches infinity. So please write those down. And each of these has the limit as x approaches infinity of this function. And some of these limits do not exist. This one, for example, does not exist. Okay, because as x increases, cosine just oscillates. Okay, it just like keeps like repeating itself. It never levels off at a certain y value, which is what an asymptote does. Okay, now this one here, 2 to the negative x, this, guys, you can actually rewrite this inside like this. This is the same as the limit as x approaches infinity. This would be 1/2 to the x, right? Because 2 to the negative 1 is a half. And if you've got a base that is a fraction and is less than 1, and you keep plugging in like bigger and bigger x values, this is getting smaller and smaller and smaller. So as x gets bigger and bigger and bigger, this is getting smaller and smaller and smaller. So that would be 0. Okay, so therefore, y equals 0 would be the horizontal asymptote for that one. Okay, so this one would have no horizontal asymptote. Now this one here, if you're doing a limit, there's something called the end behavior model. For x is approaching positive or negative infinity, if you've got a polynomial over a polynomial, you could just look at the end behavior. And what's controlling the end behavior are the highest powers. So you could just go x to the third over x. Or, by the way, you could use L'Hopital's rule, because L'Hopital's rule works for infinity over infinity also. So this is the limit as x approaches infinity of x squared, which is equal to infinity, which is a form of does not exist. So there's no horizontal asymptote. Now this one, same, let's use the end behavior model. This would be the limit as x approaches infinity of x to the fifth over x to the fifth, which would just give us 1. So therefore, y equals 1 would be the horizontal asymptote. Okay, guys, so I will talk to you later. Bye-bye.